Good morning, grade 10s. It's the 27th of May. Sorry. We'll do our video on solving by substitution. Can't remember the exact page numbers. Doesn't matter. And I'll give you a bit of work. Not much. After we do tomorrow's or Friday's video, there'll be a little more work because you can practice all the methods. Okay, so let's get down to it. So here we are on page 189 or page 174. And we already practiced last day. We worked on solving by graphing. We remember what we did is we always had two lines, and we graphed one using slope-intercept form, and then we graphed the other using slope-intercept form, and where they crossed was the solution. And we discussed about why it's not always the best way to solve a system, because what if that is not on, as you can see, that's in the middle, it's not on a specific number on the graph. So that makes it a little bit hard to get an exact answer. So there's other methods to do that, and we're going to do one of them today. So substitution is what this one's called. Now I usually tell a funny story here about substitution and elimination, which is the next method, but sadly you guys aren't going to get to hear the story. Well, you'll hear it, but it's not as fun. And I'll tell it tomorrow when I do elimination. So here we go. I'm going to use a different color for each step, and it'll help sort your work out. So here they all are. Choose one equation and solve for one variable. Now, when I say solve for a variable, everybody, it's always the same thing every kid. Oh, what do you mean solve? How can I solve for a variable? Oh, solving for a variable means isolate that variable. It's not hard to do that. We've done it a million times. So let's do that right now. We're going to have equation number 1 and equation number 2. So in red, we're going to choose one of those variables and solve for that variable. Now, I've given you a hint. Choose a letter with a coefficient of 1 or -1. It's always easier. So, where are we going to work here? Obviously, we are going to work with equation 1 because this has a coefficient of +1. So it's easy to isolate x. So equation 1 here becomes, I'm going to take this, x minus 4y equals -1, and I'm going to isolate x. So that means I got to get rid of 4y, -4y. So I'm going to move it over here. Now, a lot of you say still, ooh, what are you doing? You can't just move something. Of course I can, because what I'm really doing is adding 4y to this side. -4y plus 4y eliminates that. But if I add 4y to this side, I got to add 4y to this side. And I end up with this new equation, which is x equals 4y minus 1. Now you can see it's got all the same parts. All right? So that's step 1. We've isolated one of the variables. Step 2. I take that new equation and I substitute it into the other equation. So this is equation 2. So I'm going to take this equation right here and I'm going to substitute it into equation 2. So here we go. Equation 2 is 3x plus 5y equals 31. But x, according to this right here, x equals 4y minus 1. So instead of writing x, I can write 4y minus 1 because x equals 4y minus 1. And you guys have seen me do this before. This is one of the tricks I taught you for factoring. If something was ugly, you could change it to a single letter and substitute it in. So what I end up with is 3, not x, 4y minus 1 plus 5y equals 31. And now, please notice, instead of having 2 variables, which is impossible to do, I only have one. It's y. And then I solve for that remaining variable. I keep doing that in blue. So I'm going to get rid of this by solving for y. And remember, solving for the other variable means isolate it. So now I've got to isolate y. So I do my math. 12y minus 3 plus 5y equals 31. 12y and 5y. 17y equals, and I gotta move that 3 over there, 34. Then I divide by 17, and I get y equals 2. Now the last thing I do, I plug my solution into one of the original equations to find the other variable. So I've got all these equations kicking around now. I know what y is, but I don't know what x is. But I do know what x is because if you follow the green arrow, x equals 4y minus 1. But y equals 2. So x equals 4 times 2 minus 1, which is 8 minus 1, which is 7. So now I know x is 7, y is 2. So, as always, I check 7, 2, x, y. Now I know it works in the red equation because that's what I just did. I know the red equation is the same as equation 1, so I don't need to check equation 1. But I should check equation 2. And equation 2 is 3, not x. X is 7, plus 5, not y. Y is 2, equals 31. What's 3 times 7? 21. Plus, what's 5 times 2? 10. 21 plus 10, 31 equals 31. At least it does in the universe that I live in. It might not be the case in that crazy new universe that they've just proven exists that lives right next door to ours, where time seems to run backwards. Freaky. So, let us go on to try our next one. So here we are. We're going to follow all our same rules. We've got equation 1 and equation 2. The first thing we did was in red. We chose our equation. So I'm going to pause for a moment and let you try to decide which equation you're going to use. Obviously, we are going to use equation 1 again because y is isolated, kinda. So I have 2x plus y equals 3. Let's get y isolated. That means moving that x over here. So y equals 3 minus 2x. So there's my nice new equation. So this has to go into equation 2. Substitute. There's a great Who song called Substitute. Some of your homework should be to listen to that song. The group is the Who, the song is Substitute. Now we do that joke. You say who, and I say yes. And you say yes, and I say no, who. And then you say who is the group, and I say yes. And then you say, I'm asking you, you said yes wasn't the group. Get it? Because there's a group named Yes as well. Anyway, let's solve this. So I have 4 times x plus 3 times y, but it's not y, it's 3 minus 2x equals 1. And then I just go ahead and I solve it. 4x plus 9 minus 6x equals 1. 4 minus 6, negative 2x plus 9 equals 1. Negative 2x equals negative 8. X equals 4. Now, x equals 4. Now that is going to go up here, and I'm going to substitute again. Substitute my x for that, which is the song by The Who. Anyway, y equals 3 minus 2, not x, 4. So y equals 3 minus 8, so y equals 5. So negative 5. So now I have an answer of 4, negative 5, xy. And I have to make sure it works. I don't need to check it in there, and I don't need to check it in there because that's what I just used. So I just check it in the other one. The other one was 4, not x, times 4 plus 3 times y, but not y, because y is negative 5. Equals 1. 4 times 4 is 16, plus 3 times negative 5 is negative 15. 16 minus 15 is 1. 1 equals 1. Doesn't my universe, so I know my answer is right. Okay, let's move along. Now, notice, excuse me, that this one, equation 1, equation 2, please notice, 4, 5, 4, 5, 4, 20. 420! Ah! Barf! There's no isolated letter. But, look at that and that. They're exactly the same, aren't they? So, isn't, if I make equation 1, isn't 4x equal to 2 minus 5y? Everyone agree? I move the 5y over. Okay. And what about equation 2? Doesn't 4x equal 20y minus 3 when I move the 20y over? Sure it does. What do you see here? I'm going to take a moment for you to look at that. (4x) is that, but 4x is also that. So doesn't that mean 2 minus 5y equals 20y minus 3? What do you mean, Mr. Myers? Well, of course it does, because doesn't 2 minus 5y equal 4x? And doesn't 20 minus 4y equal 4x? And then doesn't 4x also equal 4x? Of course it does. They're the exact same thing. So I'm able to substitute again. So here we go. We work through this. And it just means isolate y. So I'm going to bring that 5 over there. So that's going to give me 25y. And I'm going to bring that 3 over there, which is going to give me 2 plus 3. 5 equals 25y. So y equals 5 over 25, which is 1/5 equals y. Now, what can I do with that? I can put it anywhere I see a y. It doesn't matter where, anywhere. So I'm going to go ahead and I'm going to put it into equation 1. Actually, that's too easy. I'm going to do the weird one. I'm going to put it into equation 2. Ooh, you crazy. So let's do this. 4x equals 20, not y, because y is 1/5, and all that, subtract 3. 4x equals 20 times 1/5 is 20 over 5 minus 3. So 4x equals 4 minus 3. So 4x equals 1. So x equals 1/4. So I have my answer now of 1/4, 1/5 x, y. And I know that that works in equation 2. So I only need to check it in equation 1. 4 times 1/4 equals 2 minus 5 times 1/5. 4 times 1/4 is 1. 2 minus 5 times 1/5 is 5/5, which is 1 equals 2 minus 1. 1 equals 1. And that works in my universe. So there you go, ladies and gentlemen. You're going to do page 191 or page 176. You're going to do these 8 questions. All right, and we will see you on Friday. Bye.